Hello and welcome back, my friends. I'm Kylan Hunt, VP of Business Development with Grow Guru. And in our last video, we talked with David Sloan about how water moves through the soil, how the soil wets up. And in this video, I want to bring David back because David is going to share with us a little bit about how soil moves through or how water moves through the soil when the soil's already wet, when the airspace is taken up, the soil's at full capacity, the water responds a little bit differently. David, you want to cue us up for what we're going to see here?
Sure. So if you remember, what we did is we took dry soil, and then the first water on had red dye in it, and you could watch it soaking through the pot and wetting up the soil.
Mm-hmm.
And so then the next water I put on had yellow dye in it, and so the bottom half of the pot was filled up with soil with yellow dye. But then all of the free pore spaces were also water with yellow dye in it, and so what I did is I left the pot for 24 hours and I came back to it. And then we put some clear water on there, just water with no dye in it. And I was really interested to see what happened. And so,
Yep.
what just to prep you, what happened was that because the column of free water in the pot had yellow dye in it, more water on the top just pushed that through like toothpaste out of a tube. And so it's called hydraulic flow. And so it's very different putting water on wet soil compared to putting water on dry soil. So if you flip over to the video, we can have a quick look and see what happened.
Sure.
So what I have here is the same pot that's been left for 24 hours. And if I just hit play, what we can
Now,
see, I put it
David,
in
can
a
I can I
clean.
can I interrupt you there just real quickly? You've mentioned 24 hours a
Sure.
couple of times. Isn't that the definition that says a field's at capacity after 24 hours, right?
Yeah, it was. I was also convenient coming back to it the next day. But yes, the laboratory definition of field capacity is what the soil can hold back against gravity 24 hours after it's been saturated. So yeah, this
Okay,
is at
I think
field
that's a
capacity.
key important point here because you are doing this as the textbook would tell us. So I think what we're about to see is pretty critical along those lines.
Yeah, but just once again, I'll say that the first water onto very dry soil had the red dye in it, and that was being held. Then what we got was yellow coming out the bottom. I've put this in a clean tray as you can see at the bottom, and if I let this run, you'll see it's just regular clear tap water going on the top, and it actually started pushing through pretty quickly, and so this is going through in real time, and you'll see if I just jump ahead a couple of minutes. So it's clear on the top, still nothing coming through. But if I just jump ahead again, now we start to see yellow coming out the bottom. Now remember, there's red dye in this pot. That was the first water on, but what's coming through because of what I originally mentioned in my first diagram in the previous video is water sticking to water. It's the weakest bond. So that water happened to have yellow dye in it, and that's just being pushed out the bottom. So I did a time lapse. I stopped and came back to it, and you can see what's really important to see is it's all yellow. There is no red coming out. So that
Mm.
red dye is being tightly held around the soil at the top. So if that's where you want to hold your nutrients, then you want to put them on dry soil. So
Wow. David, that was really cool. It didn't take that long. Did you happen to notice about
uh,
how long it took before you got started getting that water through?
I mean, the water came through very quickly because it's really just pushing, as I said, like toothpaste out of a tube. But it's a pretty heavy soil. There's a lot of silt in it, so just I said in the previous video, it took over an hour, maybe an hour and 20 minutes for the water to fully wet that dry soil. This pot is an 8-inch diameter pot, so I think it's about 8 or 9 inches deep. But
Yep.
yeah, we can probably flip back to the uh, sorry, no, back to the discussion. I was looking at a
Oh,
different screen. I apologize. Uh,
oh no, no, that's all right.
Here I am. So, um, yeah, really important stuff to know because that is a massively different reaction. Water going on wet soil compared to water going on dry soil, and uh,
Yep.
it's so knowing the soil moisture conditions before you start irrigating, you can really if you know what to expect, you can manage it. But if you don't know how wet the soil is, if you can't see that water moving through, then you can't manage it.
Yeah. Well, so another thing that I wrote down here is knowing where the plants are pulling water in. Understanding if you're putting water in from the top or if you're putting water in from the center, say with drip irrigation,
Mhm.
it's going to be a totally different response. Drip's going to respond a lot different in that scenario than, say, a center pivot would from the top down. But it's going to be important either way to really know where those plants are drawing in water from, right?
Absolutely. And since you've mentioned drip, remember that water moves through wet soil, but by gravity, right?
Yeah,
So if
yeah,
it's going to move upwards, it's going to be wicking, and so that's not from a saturated soil. That's actually moving to coat those particles. It's that wicking effect that you get, as opposed to which
yeah.
doesn't happen when it's truly saturated. Most of the saturation will move down through the profile with gravity.
Yeah. No, that's extremely important. And the other thing that I'm thinking about again is nutrition management. As we all know, from a biological standpoint, we have to have airspace for biology to work. Oxygen is really, really critical. In fact, if you've been following a lot of the top producers, they talk about hydrogen, oxygen, carbon is the big elements that make a plant produce.
Mhm.
It produces a crop, right? And so that oxygen element is really critical to the foundation of high end yields. But I'm also thinking a little bit, David, about all the rest of the nutrition. Some of the nutrients that we use, they will flow through with the soil or with the water. Some nutrients will just tie up with that water and it'll move right down through it. Others, they do get hung up in there. However, take phosphorus, for example. Diffusion is such an element to phosphorus uptake. But that comes through those little bitty root hairs on those plants, and excess water has a way of killing those off. And
Yeah.
those are things that are extremely important. But I'm thinking about that nutrition that's moving through that profile. If we're not really watching our water and understanding where the roots are pulling it up and how much we're putting on with each irrigation event and how much a rain event really affects us, if we don't know that inside the root zone, I mean, what's it costing us any given year? I mean, that looks to be a super expensive risk to me.
Absolutely, and I guess you just do the back of the envelope calculation that a lot of farmers they'll work out how much fertilizer the crop needs and then add a little bit more, but then still might end up having poor effects. And certainly, what you might find is the wetter areas actually yield less because
Hmm.
that nutrients are getting flushed through, getting flushed away, so they're not available to the crop. Or it's just being anaerobic, and so you're stopping all that microbial activity as well as the ability for the plant to take that up. So
Yeah.
um, getting it in balance is the key. Sometimes, well, not sometimes, usually, too much is actually a bad thing. So you're kind of killing the crop with kindness.
Yeah. Killing it with kindness. I look at it. That's how you describe it. I look at water as being very emotional. It's an
Mm-hmm.
emotional element in the human space. And sometimes we go out and we push start on the center pivot. It makes us feel really good, but it's stressful
Yeah,
to the plant. You know,
absolutely.
it makes us feel good because we're seeing it run.
Do you know what though, Carlin? By watching the plant response, by having sensors in the root zone, we can understand how the plant is feeling, how it's growing, how it's reacting, and so
Yeah.
we can manage that simply by watching how it grows, and then you link that together with continuous root zone management, so you can link season to season, and
Hmm.
not have any gaps. It's powerful stuff.
It is, and I think what you just showed, what you've shown me in these last couple videos, David, and I may end up putting some of these videos together, and in some places I'll leave them separate, but that was really powerful watching that come together. But what it really showed me about continuous root zone monitoring, I've got to know what the rain events are doing. I
Hmm.
need to know what my spring recharge is doing for me because if I don't know that and I need to pre-water or even if I'm going to plant first and go ahead and water after the fact, I still have to know where the existing water is and how any irrigation or any rain event is affecting that. Because you just showed me two totally different scenarios. And if I'm irrigating or if I'm getting rain, I don't know which one's happening. I don't know which one's
And
happening in my
the
soil.
crazy thing is that it's really this. Both processes are happening at the same time. So if you think about that, the wetting up, and I said how the water runs through the wet soil. Well, that
Yeah.
was really the second video, is water running through wet soil, but it's just pushing itself through until it gets to the next dry layer, and then it coats that dry layer, and then more water comes through it, and then coats out. So, you know, it doesn't. One thing doesn't necessarily have to be happening all the way through, and it's very much driven by soil texture as well.
Mm-hmm.
And so,
Mm-hmm.
sandy soils react differently to silt loam soils, and soil structure really matters. So it all comes into it. But yes, it's complicated, but it doesn't have to be. You put sensors in, and you watch what happens, and it really
Yeah.
unlocks all the secrets.
So one of the things I think we need to talk about in a follow-up video, you did a presentation here a while back, and you showed water infiltrating deep into the soil profile. And I've heard people say over the course of time that you don't want to see that. I've actually seen people train on it that you don't want water going deep really quick because that's showing a preferential pathway against a probe or things of this nature. But on our permanent installed probes, and we're seeing that water go deep, what that's really showing me is if we have drier soil down deep, we got plants that are pulling that deep water out. If we time our irrigation really well, we can get the water down deep where we need it. Is that true?
Absolutely. But you've just given me some food for thought. I think we should do some more videos on showing how that soil wets up so people really understand what they're looking at, because it does become very clear. You mentioned about water running down the side of the probe. That
Yeah.
can happen. And so bedding in time is actually very helpful. And so uh, if we can put probes out in the fall or through the winter or early spring, then they're going to be well bedded in by the time we get to the season. And then, of
Yeah.
course, you've got the next season and the next season. So uh, that time really, if there was an installation issue, that time heals, all wounds. And so you can be very confident in the data that we're getting.
Yeah, because right now we got probes that are in 5 years. It looks like they're going to track to 7 years in there. We don't have to replace that thing. That thing is very well set in. It's basically back in against virgin soil, right?
Yeah, it really is, and so there are signatures also that we can look at that give you confidence that we've got a good installation. Bad installations are pretty easy to pick, and um, so the other beautiful thing about having permanent probes is that you can have a higher caliber installation team as well. You've got
Mm,
more time to do it, and so you don't have an army of 10 or 15 installers out there sort of trying to get 15 or 20 probes put in a day and really rushing.
yeah,
We can take the time to put them in right.
yeah. Well, David, this has been amazing. Thank you again for investing some time with us. I've got so many questions starting to accumulate on this, including oxygen, airspace management, so many other things that I believe we can start learning and capable of doing with soil sensors. So I do appreciate your time and your willingness to be a part of this. And anything else you want to share before we jump off here?
Uh, Only that yeah, we can put together, we will put together a whole series of data signatures. So stay tuned,
Okay.
and we'll bring them to you.
Awesome. Awesome. Well, I'm anxious to start going through those. So thanks again for your time, David. There we have it, Dr. David Sloan sharing with us how water, when you've got a soil profile at full capacity and you pour water in it, it's a totally different response than drier soil. And again, as he said in the middle of this video, some of that is happening, both times. Both of those actions are taking place in certain soil conditions. So, my friends, there's just so many things for us to learn about how water moves through soil and how our plants are accessing it. So, stay in tune with us. Click the subscribe button below this video, and you'll get all of our updates. As we bring more and more videos in, we want you to get the updates. We want you to be a part of what we're doing. So, don't miss out. Follow us on YouTube, hit the subscribe button, get our updates, and I guarantee you, my friends, you're going to start learning alongside us, and you may even start seeing things that you can send us questions about. Let us know what you're seeing, and we'll do the research. We will find out what's happening. We'll put sensors out with you. We will learn together. So let's keep moving. We've got a couple of other videos we want to shoot here yet with Dr. David Sloan while he's here. So thank you very much. We'll catch up with you on here in just a few days. God bless, my friends. Make it awesome.